As promised, here is the video on molarity. So the word that we need to be aware of is something called concentration. It describes how much of a sample, how much matter is dissolved inside of a sample. So typically in our everyday lives, we don't really use this very often. Shampoos are created with certain molarities, different chemicals, like when you go to medicines, like if you're ordering a sample of some type of a medicine and the pharmacist has to mix it up, a lot of times those will use molarity. In our everyday lives, we don't use molarity very often. We just talk about it in a science class as being the amount of matter in a given sample. All right, so that is concentration. In chemistry, very specifically, we use molarity. And molarity, as you can see here, is the term that we use to describe the number of moles of solute in 1 liter of solution. The problem is we don't always have 1 liter of solution. Sometimes we'll have a bottle that's 500 milliliters. Sometimes we'll use a smaller sample that's like 200 milliliters or 250. Again, a liter is a lot of stuff. So typically we don't like to use 1 liter all the time. But the problem is when you're trying to make like Kool-Aid, you have to make 2 quarts, which is about a liter. If you're going to be making orange juice using the orange juice concentrate, it has to be a specific quantity because that's how we're making these things. So like even your little Kool-Aid singles, right? Or these little guys, these little Crystal Light guys. So these little things these have been designed with the right amount of solute to pour into your solvent so that it is the proper concentration and it tastes right. If I use this in a half full bottle of water, it's not going to taste right. It's going to be too concentrated, too much solute for the amount of solvent. And if I use this in like a 2-liter bottle of water, this is going to be way too dilute. There's not enough solute for the amount of solvent that we have. So that's what we're looking at. So molarity allows us to make whatever concentration we want at whatever volume we want. All right, and it just uses this idea of moles divided by liters. So you're going to take whatever value they give you some number of moles, and some volume, and it has to be moles per liter, moles divided by liters. All right, so you take the grams, convert to moles, and then divide by liters, not of water and not of solvent, but of solution. The idea here is it's the total amount of solution, not how much water I use. So again, if I went back to this sample here, let's just pretend it's 250 milliliters. If I were to pour the powder in, what happens to my volume? The powder actually takes up space. So it's going to expand, and it's not going to be exactly 250 milliliters anymore. It'll be like 251 or 252, which actually changes our concentration, right? So it's the amount of water to make a given volume of solution. So the idea is it's not like if I add it to 1 liter of water, the volume is going to go up, all right? So it's always that way. So let's just do a couple of these calculation problems. I'll just leave it up here on the board for a moment. I'll read it out loud, and then I'll work through it so you can see what we're doing. If 34.2 grams of calcium chloride is dissolved in enough water, see there's that phrase again, enough water, to make 250 milliliters of solution, calculate the molarity. So molarity, again, we talked about this a moment ago. Molarity is moles per liter. They didn't give me moles, they gave me grams. So you got to take the grams and convert to moles. This has got to become a seamless thing that no matter what, they give you grams, you're like, oh, I got this, converting grams to moles. So I'm going to take my 34.2 grams, and I'm going to divide by the molar mass of CaCl2. If you go look on your periodic table and you add these things up, this becomes 110.98 grams per mole. So if I divide 34.2 divided by 110.98, I get 0.308 moles. 0.308 moles. 34.2 grams is this many moles of calcium chloride. But again, it says find the molarity, and molarity is moles per liter. So I'm going to divide by the amount of liters that I have. 250 milliliters is not liters, that's milliliters. The prefix milli means 1/1000th. So this is 0.250 liters. To convert from milliliters to liters, you move the decimal 3 places left. You divide by 1,000. So now I'm going to take my 0.308 divided by 0.250, and I get a molarity of 1.23 molar, is how we say it. It's 1.23 molar solution. Hopefully that makes a little bit of sense. Let's do another one. This time it says the solution is prepared using this stuff. So I did this on purpose to introduce a new concept that we never talked about before. It's when something has this dot H2O written after it. This is called a hydrate. And what happens is the particles of the solid, like they hold onto water molecules as part of their crystalline structure. So when I go to dissolve this stuff, if I had 1 mole of this stuff, magnesium sulfate heptahydrate, there would be 1 mole of all this stuff would release 7 moles of water. There's 7 water molecules stuck onto every crystal. So when I go to find the molar mass, it's not just the MgSO4. I have to also include 7 waters in the mass. So this thing's molar mass ends up being, so I'll just write MM for this thing. I already wrote it down on my paper, is 246.52 grams per mole. That's the molar mass, right? 246.52 grams per mole. They're saying the solution is being prepared using this many grams and putting it in 750 milliliters. Again, that's not liters. We're going to have to do a conversion there. This is not moles. I've got to do a conversion there. So the first thing I have to do is I'm going to take my 45.9 grams that was given, and I'm going to divide by the molar mass, 246.52. This is going to tell me how many moles of stuff I'm beginning with. So 45.9 divided by 246.52, that gives me 0.186 moles. Easy. Convert grams to moles, done. Divide by the volume, milliliters. 750 milliliters is 0.75 liters. And my volume, molarity divided by volume, is 0.248. 248 molar solution. All right? Take the grams, convert to moles, divide by liters of solution. The other thing we can do is we can go the other direction. What if we know our concentration and we want to know how much stuff is in that solution? So if I went over into the rack over there and I pulled out this bottle of 0.37 molar copper 2 nitrate, how many grams would there be dissolved in 400 milliliters of solution? Well, what we'd be saying is if I evaporate away all the water, how much stuff is left behind? So we're going to use the same concept, molarity equals moles per liter, but this time you use molarity to figure out how many moles there are and convert that back to grams. So my molarity of 0.37 is equal to some number of moles that I don't know, and I know I have 400 milliliters, which is 0.4 liters. So now I'm going to do algebra to solve for moles. If I multiply both sides by 0.4, that will get rid of the value on the bottom. So this was molarity, by the way, capital M. Molarity times volume gives you moles. 0.37 times 0.4 is 0.148 moles. That's how many moles of copper 2 nitrate are in 400 milliliters. But the question didn't want moles, it said how many grams. So now to go from moles to grams, I need to multiply by the molar mass. The molar mass of copper 2 nitrate is 187.57. So I'm going to multiply this by 187.57 grams per mole. And we end up with times 187.57, 27.8 grams of solute. So hopefully this is starting to make sense. All I can do is show you how to do it. You have molarity. You can use this formula to solve for moles. And then what we've been talking about for 2 weeks, convert moles to grams by multiplying by its molar mass. Let's do one more of this style. This time it's going to be a little bit different. We want to know, how can I get 25 grams out of this stuff? On my rack over there, I've got a solution of powder dissolved inside the solution. I want to evaporate away the water. I'll boil it slowly, make the water fly away, or recrystallize the stuff, but I need 25 grams. So again, they were like, wait, what? What are you talking about? How can I get 25 grams of stuff? Well, I need to know how many moles that's going to be, and then what volume of stuff will I need. So I got to do the other part first, convert grams to moles to know what goes on the top of my M equals moles over, so we got this for M equals moles over liters. I know the molarity is 0.5, right? 0.5 molarity. I know the number of moles, but not yet. I know it, but I don't know it, right? I have to convert the 25 grams into moles, and then I'm going to solve for how many liters of solution I need to figure that out. So let's do this other calculation. 25 grams of sodium phosphate. So 25 grams. We're going to divide by the molar mass of sodium phosphate. I didn't write that one down. So sodium is 22.99 times 3, and a 3 plus a phosphorus plus 4 oxygens is 163.94. grams per mole. So if I take 25 divided by that, I get 0.152 moles. So now I have moles per liter, and now I got to do some math. This is like, it's algebra. You should know how to do this, but I know a lot of you really struggle with it. I'm going to cross multiply both sides by x, and then divide. So it's going to end up being x liters equals 0.152 divided by 0.50. And so x is going to be, I believe that's just 0.304. 0.30. So because of the rounding error, like I had rounded it to 3 significant figures. Now when I do the next problem, it was still in the calculator. So it ends up giving me a different answer than you'd expect. It's 0.305. 0.305 what? This is 0.305 liters. So what volume do I need? It's 0.305 liters. Or we could also call that 305 milliliters. So this is the concept of molarity. You take the grams, convert to moles, then divide by liters of solution. If you're trying to use molarity to find grams, then you just do what it says to do. Like you just plug in and solve for moles and convert moles back to grams. All right? There's going to be another video that you should watch. It is a video that was made a long time ago and it has a song that we will learn, and you'll recognize some of the words that I just said about take the grams, convert to moles, and divide by liters of solution. And you'll hear that, and then we'll have a way to be able to remember it. So hopefully this is helpful, and we'll talk more in the near future about molarity.